Okay, Form 6. In the lesson yesterday, we looked a little bit at the graph transformations, and you started exercise 5.2, and some of you had got as far as kind of question 3, 4. So what I thought we'd do at the start of the lesson is that I'd like you to have a go at questions 5, 6 and 7 from that exercise. What I'm going to do in this video is I'm going to go over the answers to each of those. So it may be that you want to do question 5, pause the video, do question 5, then watch the answer to question 5, then pause and do question 6, watch the answer, or do all 3 and then watch the answer to all 3. It's up to you. But I'll start working through the answers now, so you can pause the video and go and do some of them and then come back and check what you've done. So question 5, it says the diagram shows a graph of y equals e to the x. So this e to the x is what our function is. And there's a graph drawn. We know what this graph looks like. It's going like that, crossing through 1. And then it says, sketch the graphs, label the point. So for part A, it says we want to draw the graph of e x minus 3. So this x minus 3 bit here is kind of taking the place here where the x was. So this must be f of x minus 3. So I want to replace the x with x minus 3. So it goes inside the brackets. And then you know what that does. That moves the graph to the right 3 places. So this 0, 1 point, in this case, would move to the point 3, 1. Okay, for part B then, I'm not going to sketch the graphs. For part B, it is y equals e to the x add 1. So this bit is just the fx. That's what our fx was. And then we've added 1. So this is fx plus 1 outside the brackets. So outside the brackets, it affects the y coordinates. So the y coordinates all move up 1 place. So instead of this point being 0, 1, it would now be at the point 0, 2. Part C, it says what is 0.1 e to the x. So again, this e to the x is just your function. And we're times it by 0.1. This is 0.1 f of x. So that's a stretch in this direction by 0.1, or all the y coordinates are times by 0.1. In fact, if it gets smaller, it would squash. So you have the point 0, 1. If you times your y coordinate by 0.1, it would go to 0, 0.1. And then for D, it was y equals minus 4 e to the x. So again, same as the last one. This e to the x is just f of x. So it's minus 4 times f of x. So you times all your y coordinates by minus 4. So it's going to stretch it 4 times as big, but also reflect it or flip it over. So the coordinates instead of 0, 1 would go to 0, minus 4. And it will be a reflection over the x-axis, won't it? And then the last one for E, we've got e to the 7x. So this time, instead of e to the x has been replaced by 7x. That's f of 7x. So this one is the squash this way by 7, or a stretch of 1/7, or the x coordinates are all divided by 7, or they're times by 7th. But the x coordinate of the point is originally 0, so that's going to stay as 0, 1. Although your graph will kind of squash in a bit and not be quite as wide. It'll look like it's going a bit steeper on that one. Okay, question 6 then. So for question 6, you're given a graph. So the graph of y equals, or it's fx actually. So it says fx equals x squared minus 3x plus 3. is transformed to give the graph of gx. Give the equation of gx if the transformation is. So that's my fx. So I want to work out gx, and gx is a vertical stretch of this. So for part A, a vertical stretch with a scale factor of 2. That means I want to stretch it up and down this way by 2. I want the y coordinates always to be times by 2, so that's going to be 2f of x. And all I'd need to do to work out that then for this one, it's going to be g of x equals 2 times this, or I could write that as 2x squared minus 6x plus 6. B then asks us to do a translation by minus 3, 0. So a translation by minus 3, 0 means we want to move the graph 3 to the left and then none up or down. So that would be f of x plus 3 if I want to move it 3 to the left. So my g of x is going to be this f of x that I've got up here, this one. But everywhere where there was an x, I'm now going to replace it with this x plus 3. So if I do that, that gives me x plus 3 squared minus 3x plus 3 plus 3. And the question does say give this in its simplest form. So we're going to need to multiply this out. So x plus 3 all squared will be x squared plus 6x plus 9 minus 3 times x is 3x plus 9 plus 3. So I've got x squared. I've got 6x minus 3x, 3x. I've got 9 minus 9 plus 3, so that's plus 3. So I've got x squared plus 3x plus 3 as my simplified version. And for C, it's a horizontal stretch. And this time it's a scale factor of 0.25 or a quarter. And if I want to make it a quarter the size, I'd have to divide by 4. So what I want is this. So again, I go back up to my fx, which was x squared minus 3x plus 3. And instead of the x, I'm going to put the 4x. So x squared minus 3 of my x plus 3. And that's going to give me 4x squared, that's 16x squared, minus 12x plus 3. Okay, that's everything for question 6. So lastly, question 7. So question 7 says sketch the graph of fx equals x squared minus 6x minus 7, showing clearly the points, the coordinates of maximum and minimum and where the curve meets the axes. So x squared is positive, so I know this is going to have a minimum turning point, and I want to find where it crosses the axes. So the first thing I'm going to do is try and factorise this. And two numbers that multiply to give minus 7 and add to give minus 6 are minus 7 and plus 1. So I know that it crosses the axes when that equals 0. So if we make the graph equal to 0, or when y is 0, x must be 7 or x must be minus 1. So my graph is going to cross at 7 and minus 1. To find the minimum point or the maximum point, the easiest way to do that is by completing the square. So that's it factorised. If I were to do completing the square with this, if I've got, I'll just write it above so I can keep track of what I'm doing. I completed the square form, half of 6 is 3. If I multiply that out, I get 9. I did minus 7, so I'm going to minus 16 at the end. So the minimum point is going to be when this bracket is 0, so x would be 3. And when the bracket is 0, the whole thing is minus 16. So I've got here everything I need to know about this graph. So it's crossing the x-axis at -1 and 7. So that's -1, 7. The minimum point here is 3 minus 16. And it's obviously crossing the y-axis here when x is 0. So if we look back up to this fx graph, up here when x is 0, that would just be -7. So that's -7 on that axis. So that's part A, that's my graph drawn. And it says write down an equation of the graph obtained by stretching the graph of fx vertically with a scale factor of -2. So I want to stretch it vertically with a scale factor of -2. What I want is -2 f of x. And that will simply be -2 times x squared minus 6x minus 7, which is -2x squared plus 12x plus 14. That's your stretch of -2. And then it says sketch the graph of the equation you found, showing clearly the coordinates of any maximum and minimum points and where the curve meets the axes. So if I've done a vertical stretch by -2, the minus will have flipped it and the y coordinates will have doubled, won't it? So if I wanted to sketch this, it's going to have flipped over. So it's going to have flipped up this direction. These 2 points, -1 and 7, are going to stay the same because they aren't going to have changed. This point is still going to be at 3, but if I've times it by -2, it was at -16, so it's going to move to 32. And if I've times by -2, the 7 is going to move to 14. That's how that one's going to change and move. Okay, once you've done and marked that, we're going to move on and do the next little bit. And I'm just going to give you some notes on circles and maybe just a few questions for you to have a go at on this one. So in your notebooks, you can take down a new title, which is going to be circles, an equation of a circle. So this little section is on what the equation of a circle is if I want to draw a circle. And I'm going to just prove this to you or show you how it works now a little bit. So if I were to draw a circle on a coordinate axis, so I'm going to draw it on an XY grid. If I were to draw a circle, let's say here, with the centre at the origin, I know it doesn't look quite circle-like, but you get the idea, the centre at the origin, what is my rule between my x and y coordinates and the radius? And really, all you have to do to prove this is say, let's pick a point here. And I'm going to say that point is the point x, y. The x coordinate's x, the y coordinate's y. And this has a radius of r. And if we just look at that as a little right-angled triangle, this height will simply be y, because it's just how high it is, and this one would simply be x. And using Pythagoras' theorem, we get the equation of a circle. So if the centre is there at 0, 0, the equation of the circle is simply x squared plus y squared equals r squared, where r is the radius. It's slightly different if we want to move that centre. So that's fine if we want to always draw graphs where the centre is at the origin, but sometimes we might want to draw a graph where the centre is somewhere different. So if I were to draw an axis again, x and y, and this time I'm going to put the centre of my circle here at the point A, B, and I'm going to draw a circle again with radius. That's terrible. Have another go at that. Oops. Let's draw a circle with radius r from here. So if I draw a circle, still terrible, but it doesn't matter, with radius r, and let's say that's now my point x, y. So this coordinate's x and this coordinate is y. If I were to now draw in a little right-angled triangle in here, if I look along the bottom here, this value, so this distance, if the whole way across to here is x, but across to here is a, that one would be x minus a. For this length, if this is the coordinate y, but we're only going down to b, that would be y minus b. And that, this time, if I use Pythagoras, gives me the general equation of any circle. And the general equation of any circle is x minus a squared plus y minus b squared equals r squared. And that's where the radius is r and the centre of the circle is at the coordinates a, b. Okay, let's just do one little example of this then. So for my example on this one, let's do two. So question one would be, if I want to work out the general equation of a circle that has centre 3, 6 and radius 5. Just remember the equation. It is x minus a squared plus y minus b squared equals r squared, where the centre is ab. So this one's easy. That one's just x minus 3 all squared plus y minus 6 all squared equals 5 squared. If I did it the other way around and I gave you the equation of a circle, let's say I gave you the equation x minus 3 squared plus y plus 5 squared equals 7 squared. And I said, what's the centre and what's the radius? For this one, just compare it with the general equation. So if I compare that with the general equation, the radius is easy by just comparing these. So the radius is simply 7. And the centre is that AB value. So here it's really obvious, A is 3. Be careful with the B here. So this is minus B, but I've got in here plus 5. So the centre has to be at 3 minus 5, because we've got that kind of negative in there. So the B value is minus 5. And if you still have some time, let's have a quick go at a few of the straightforward questions on page 52, exercise 6.1, and let's do questions 1 to 3. So 1, 2 and 3 on that exercise. Hopefully you get that finished. If you have those finished, you can go on and try 4 and 5 if you've still got time in this lesson. But don't worry if you don't. Have a lovely half term, and hopefully I will see you all in a few weeks.